So this is question number 2 from page 37 of the Kinematics workbook. Question says, a cougar is crouched on the branch of a tree that is 3.82 meters above the ground. She sees an unsuspecting rabbit on the ground sitting 4.12 meters away from the spot directly below the branch on which she's crouched. So it's asking us at what horizontal velocity should the cougar jump from the branch in order to land at the exact location of the rabbit. And we're also given a hint to consider the cougar's vertical fall time. So first we can list our givens. So we're given the displacement in the y direction, which is just how far she is from the ground. So that's going to be 3.82 meters. We're also given the displacement in the x direction, which is how far away from the rabbit she is, and that is 4.12 meters. We also have acceleration in the y direction, which is going to be 9.81 meters per second squared, and that's just due to gravity. And we also can infer that the acceleration in the x direction is going to be 0 meters per second squared, as always. And we can also say that since the cougar is jumping just horizontally, she's not being launched up or down, that the initial velocity in the y direction is also 0 meters per second. So we're asked first to find the fall time, and then we'll use that to find the initial velocity in the x direction. So to solve for this, we're going to have to use one of the 5 equations. Specifically, equation number 3 works, and that is because, at least in the y direction, we are given displacement, we have acceleration, and we have the initial velocity, and that will allow us to solve for time. So we can use displacement in the y direction equals initial velocity in the y direction times change in time plus 1/2 acceleration times time squared. Now, because the initial velocity in the y direction is 0, we can get rid of this part of the equation because that will all equal 0. So we're left with displacement equals 1/2 acceleration times time squared. And the first thing we can do is get rid of this half by doubling both sides of the equation. So we have 2 delta dy equals ay delta t squared. And next we can get rid of the acceleration by dividing both sides by acceleration. So we have 2 delta dy over ay equals delta t squared. And the last thing we have to get rid of is the squared. So we can just square root both sides. So we have square root of 2 delta dy over ay equals delta t. Now we can just put in the numbers. So we have time equals the square root of 2, and then the displacement in the y direction, which is 3.82 meters, and that's going to be over 9.81 meters per second squared from gravity. And then we can break it down into steps to make it simpler. So we can do 2 times 3.82, which gives us 7.64, and that's going to still be meters. over 9.81 meters per second squared. And then when you divide that, it gives us 0.77880. And for the units, we have the meters canceling out. So we're left with seconds squared. And then we can square root the whole thing, so it's going to be 0.88249 if we carry 2 extra significant figures. And then because we square rooted it, we get rid of the squared. So it's just in seconds. So to round to 3 significant figures, which we have in both of the givens, this just becomes 0.882. And that is going to be our time for obviously both the x and y directions. It's going to stay the same. So now we're able to solve for the initial velocity in the x direction. And as for the equation, we can use the same equation actually, because in the x direction we now have displacement, acceleration, and time, and that will allow us to solve for initial velocity. So we can use delta dx now equals vix delta t plus 1/2 acceleration in the x direction delta t squared. And for the x direction, our acceleration is 0, so this whole part of the equation will be equal to 0. So now we have delta dx equals vix delta t, and all we have to get rid of is the time, so we just divide both sides by time. So we have delta dx over delta t equals initial velocity in the x direction. And then we can solve for this now. It's going to be 4.12 meters over the time we got. And we're going to use the unrounded value as always. Now that we're inputting it into this equation. And when we divide that, we get 4.6686. And because it is just meters over seconds, it's going to be meters per second. And then again, to round to 3 significant figures, we can do 4.67 meters per second. And that's our initial velocity solved for. And we can just write a final concluding sentence. And we can say the cougar's initial horizontal velocity must be 4.67 meters per second. And that's this question solved.